Hello everyone, this is Rebecca and I am from G1 and G2 Maths Learning Community. This morning, we are going to learn something and it is from the topic of simultaneous equations. Simultaneous equations is a topic that is covered in the G1 syllabus in Secondary 3 and the G2 syllabus in Secondary 2. Let me open the slides and I will begin a short presentation. So today, I will be sharing an easier method to solving simultaneous equations. And you might wonder just why. Well, before I even came up with an easier method to solve for simultaneous equations, I have been teaching this to students for a number of years. From textbooks and numerous resources, we will know that there are two traditional methods used to learn this topic. One is by elimination method, and the other is by means of substitution. While these two may be efficient, it requires quite a good amount of algebraic knowledge in order to execute the steps well and accurately. And for students who may be struggling with algebra, this is indeed not easy at all. So I thought of a way to come up of something that is easier, also considered a substitution method, but this one does provide more structure to the learner who is struggling in the above two methods. So if you would like to search for something that is easier to manage on the algebraic scale, do listen in with me and learn as well. Let me just run through the steps of how this method works before we take a look at solid examples. So number one, when we receive a question containing the two equations to be solved simultaneously, we divide the solution space into two columns. 2. Write the first equation at the top of the first column. 3. Write the second equation at the top of the second column. 4. Make the x term the subject of each column. 5. We equalize the coefficients of both x terms by finding their common multiple. Following that, equate the left-hand side of both equations. I think I will need to make a short change here. It's actually the right-hand side. 7, we solve for the value of y. 8, we substitute this value of y into the equation written on the top left-hand column. And finally, we solve for the value of x. Now, if you look at the steps that I have just narrated out to you, you will realize that it is kind of rigid, right? So if I were to look back at the steps, in step 1, you're required to divide the solution space into two columns. Yes, we want to have two columns so that it provides good enough structure and make it so rigid that it's easy to follow step 1 to step 2. And then first equation goes on to the top and not anywhere else of the first column. Second equation, again, top of the second column. Now, following that, for each equation, we are going to make the x term the subject of each column. I do not require you to make the x term coefficient of 1. No. If the x term is 3x, we leave it as 3x on the left-hand side. If the x term is 10x, we'll leave it as 10x on the left-hand side. Now next, we move on to equalize. That means to make the same, the coefficients of both x terms by finding their common multiple. Following that, equate the right-hand side of both equations, and we solve for the value of y. Okay, so solving for the value of y is another topic altogether, solving simultaneous equations, and I will not go into that in detail. Following that, we substitute this value of y into the equation written, again, this time around, I'm just going to limit it to the one written at the top left-hand column. Let's not leave room or space for ambiguity to think, which equation should I substitute it into? Let's just not think too much, but put it right, substitute it right at the first equation on the top left column. And finally, we solve for the value of x. And again, this is the step I will not delve too deeply into because I will assume that you are able to solve for linear equations. Let me go into a few questions so that you can better understand where I'm coming from. This would be a typical question, and I have taken this from the Maths 20/20 textbook from G1. All right, so we have one equation at the top and the second equation at the bottom. First step, remember, we want to divide the working space into two columns. First column on the left, I am going to put down the first equation. So I'm going to put down x plus 2y equals to 6. And the second equation goes onto the top right-hand corner. 3x plus 2y equals to 14. Okay, now next step, if you can recall, I am now going to make the x term the subject of each equation. Now, where is my x term? On my first equation on the left, my x term is here. Okay? So x will remain on the left, and this means that my plus 2y term will move over to the right. How do I do this? My x remains. So if plus 2y term goes over to the right, it will be the sign here, instead of addition, it will be subtraction already. So it will be 6 take away 2y. I will do the same for the second equation, which is on the right. So this is my x term. I'm going to leave this on the left. So this means that my plus 2y goes over to the right-hand side as well. There goes. Following this, now let's take a look at the two equations. The one on the left tells you x equals to 6 minus 2y. The one on the right tells you that is 3x equals to 14 minus 2y. So if I have an x term here and I have a 3x term here, what do I need to do to this x so that I can make it the same, 3x? From x to 3x, I need to multiply the equation by 3. Okay, so this is what I mean by to equalize both equations. So when I multiply the whole equation by 3, 3 times x, I get 3x. 3 times 6, I get 18. 3 multiplied by negative 2y, I get negative 6y. Okay, now at this point, what do you notice? Left-hand side of both equations is 3x. So this means that the two equations are equal. And when they are equal, then the right-hand side of the equations must then be equal to each other. And that is the next important step, where I put the right-hand side of both equations, equate them to each other. So therefore, 18 take away 6y must be equals to 14 take away 2y. Let's now solve for the value of y. So to solve for the value of y, we have to eliminate all constant terms from the left-hand side. So if I want to take away 18, I'll put down minus 18 on both sides of the equation. And if I want to have no y terms on my right-hand side, I need to plus 2y on both sides of the equation. Okay, so now I will be able to come up with something. 18 take away 18. This is gone. This term is gone. Now this gives you negative 6y plus 2y. I will get negative 4y. Put the equal sign down. Now here, I will have 14 take away 18. That's negative 4. And negative 2y plus 2y, that's nothing. So from here, I can solve for y. Y equals to negative 4 divided by negative 4, which is 1. Now that I have my value of y, I want to find my value of x. So in the following step, I'm going to substitute this value of y into the first equation on the top left-hand corner. Okay, so my first equation says x plus 2y equals to 6. So x plus 2y. Y, I replace it with 1 equals to 6. From here, I'll simplify. So 2 multiplied by 1 gives me 2. And from here, I am able to solve for the value of y, of x. So therefore, x equals to 4 and y equals to 1. I'm going to move on to the next question, which will be similar to this. Now, this is the next question. 2x minus y equals to 5, x minus y equals to 2. First step, we divide the solution space into two halves. First equation, we write it at the top left-hand corner. Second equation, write it on the top right-hand corner. Next, let's identify the x terms that we want to leave on the left-hand side of the equation. Once we identify the x terms, everything else that's on the left-hand side of the equation, we do not want it there. We move it over to the right side of the equation. So for the first equation, it will be 2x equals to 5 plus y. Okay, so negative y, I move it over. I will have positive y. Now, on the other side, my x remains. X equals to 2 plus y. Because my negative y, when I move it over, I get positive y. Now, next, I will have to look at my x terms on the right-hand side. I have 2x on the left, and I have x on the right. So what I need to do next is to make sure that I have 2x on each side. So what do I need to do to this x over here, this x term? I must times 2, right? So when I multiply this by 2, I will get 2x on my left-hand side of the equation. And subsequently, all other terms on the right-hand side will also be multiplied by 2. So I will have 2x, 2 times 2, 4, positive y multiplied by 2, positive 2y. Now, this is where you see that on both sides of the equation, I'll have 2x equals to 5 plus y, 2x again equals to 4 plus 2y. So if both equations have got 2x on the left-hand side, then we could very well say that the right-hand side of the equations must be equal. So the next step, we're going to put both parts of the equation together. We have 5 plus y equals to 4 plus 2y. Okay. Now we are going to solve for y. So our y term stays on the left. I take away the 5. Our y term is removed from the right. So I'll take away 2y. Okay, and let's try to simplify it. So 5 take away 5, this is gone. Y take away 2y, I get minus y. 4 take away 5, negative 1. 2y take away 2y, none. So y equals to negative 1 divided by negative 1 equals to 1. Next step, I'm going to now substitute y equals to 1 into the top left-hand equation. So my left-hand equation, the equation on the left-hand side says 2x minus y equals to 5. So 2x minus, okay, instead of y, I'm going to replace it with the number 1 equals to 5. So 2x would be then 5 plus 1, which is 6. And then x would be 6 divided by 2, which is 3. So therefore, x equals to 3 and y equals to 1. Finally, we are moving on to one more question, and this is probably the most challenging question that you could find. Now, let's take a look at the coefficients. Oh, one says 2 and one says 3. Interesting. When you see a difficult question or a question that you are unfamiliar with, continue to follow the steps. Trust the process. We will still be able to get to the solution right at the end. So what is our first step? Divide the solution space into 2 halves. First equation, write it on the left. Second equation, write it on the right. Next step, we identify our x term, and this is the term we want to leave on the left-hand side of the equation. So if we want to leave this on the left-hand side of the equation, our positive y has to go to the other side. When positive y goes over, it will become negative y. For the equation on the right, I leave my 3x. Positive 2y goes over to the right-hand side of the equation. It will become negative 2y. Okay, now the next thing we want to take note of is these 2 equations. I have to find a way to make my coefficient of x the same. So if I have If I have 2 as a coefficient on for x on the left-hand side and 3 on the right-hand side, what is a common multiple of 2 and 3 that I can think of? If you have if you are good in multiplication table and you are able to come up with it right on the spot, great. For some who may be struggling to decide what is a common multiple of 2 and 3, use your calculator, press in 2, multiply by 3. That will give you one common multiple. So what is 2 times 3? 2 times 3 gives you 6. Okay, so this will be the common multiple of both x coefficients. This means that my 2x will now, something has to be done to 2x to make it become 6x. So how do I make it become 6x? From 2 to 6, I need to multiply it by 3. And from 3x to make it become 6x, I need to multiply it by 2. Okay, so let's see what happens. When I take 2x multiplied by 3, I will end up with 6x. 3 times 3, I get 9. Negative y times 3, negative 3y. On the right-hand side, I am now going to multiply each term by 2. So 3x times 2, I will get 6x. 4 times 2, I will get 8. And negative 2y times 2, I will get negative 4y. Okay, let's pause here to take a look at both equations. And you will see that both equations start off now with 6x. Hooray! So if it starts off with 6x, then we can say that the right-hand side of both equations are now equal. When they are equal, I guess now you know what to do. We will equate them. So 9 take away 3y equals to 8 take away 4y. Let's try to simplify this. So we want to leave our y term on the left. Let's remove 9. We minus 9 on both sides of the equation. We don't want our y term to be on the right. So let's add 4y to each side. Now we can simplify. 9 take away 9, that's nothing. That's 0. Negative 3y plus 4y, we end up with y. 8 take away 9, negative 1. Negative 4y plus 4y, nothing. So y is negative 1. And the next step, we are going to substitute the value of y equals negative 1 into the top left equation of the page. So 2x plus y. I'm now going to replace it with negative 1. Now take note that since it's a negative number, I've bracketed the entire negative 1. Now let's simplify. When we simplify, we have to also take note that this portion here, when you add a negative number, you end up with 2x minus 1. That's equals to 3. Now we solve for x. So 2x, 3 plus 1, and x, 4 divided by 2, is 2. So therefore, x is equals to 2, y equals to negative 1. I hope this short session is helpful to you in terms of solving for simultaneous equation. While it is still quite a number of steps, this is probably the most simplified method that I could think of. However, if you have something that is easier to share on your end, why not share with me? Do write into me, PM to me under Facebook page, Facebook groups, G1 and G2 Maths Learning Community, and I would love to get in touch with you. So take care, and I hope to hear from everyone soon. Bye.